In this lecture, we are going to discuss about stream control transmission protocol. So in the previous lecture, we have seen about a few topics related with the TCP and UDP. So it's a continuation of this. So what is stream control protocol? This also lies in the same layer where TCP and UDP lies. In TCP, we know the difference between TCP and UDP first. So TCP is a connection-oriented protocol and UDP is a connectionless protocol. So it's a combination of both the TCP as well as UDP. So it stands for SCTP, Stream Control Transmission Protocol. It's also a connection-oriented protocol which provides a full duplex communication. So it is similar to that of a telephonic conversation. Anyone can send any data at the same time. So this TCP is specially for establishing a connection over wireless network and managing the transmission of multimedia data. So we will see some features related with SCTP, how it is going to be useful when we compare with the TCP and UDP. So usually in TCP we send the data in multiple data packets. We divide the data into multiple fragments that will be forwarded. Similarly in SCTP we forward the data in streams of data chunks. So multiple streams are there. Each and every stream will forward the data chunks. So when we take a collaboration of both of them, streams of each and every data, and in each stream multiple set of data will be forwarded, that is called as data chunks. So from the sender side, a stream of data chunks will be transmitted, multiple streams will be there, and at the receiver side, it has to collect all the streams of data chunks and do the ordering of data before it is going to extract the original data. So few features what we have seen in SCTP. Similar to TCP, here a unit of data in TCP is specified as a byte. So here all the data packets are controlled by a sequence number. So here also we have a transmission sequence number. So this is mainly needed in order to do the ordering of packets at the receiver side. Then a stream identifier. Since we have multiple streams in SCTP, we take each and every stream, and each and every stream we can have multiple sequence numbers. So we have each and every stream is identified by a stream identifier. So each stream will have its identifier, and in each stream we have multiple packets will be forwarded, fragments of packets, and each and every fragments they have their own sequence number. Apart from these two special identifiers, we have stream sequence number. So when any data chunk arrives at the destination site, we need to take the data in a proper order to deliver it. So at the receiver side, a stream sequence number, it specifies which stream and in the stream which sequence it holds. So both of them will be combined together to represent the stream sequence number. So three identifiers were used in order to order the data. The first one is a transmission sequence number, stream identifier, and stream sequence number. And whatever data we forward here in the TCP, the segments carries data as well as the control information. So hope you know very well about the packet format of TCP, where data will be forwarded in the header along with header, and inside the header we have few more fragments, that is bits, that are specially assigned for flag variables. So there are 6 flag variables in TCP, whereas in SCTP we take the data as a data chunk and all control information specially as control chunks. So control chunks are there specially in order to identify the status of the data where it is going to be forwarded. And flow control. So when we compare with the TCP, flow control mechanisms are here, and at the receiver side, to avoid overwhelming of data packets, flow control mechanisms will be there, and error control mechanisms. So definitely by using the TSN, that is transmission sequence number, error control mechanisms are carried out. So acknowledgements of each and every packet will identified by their acknowledgement number. So these two numbers will specify is there any packet or modified in our data transmission. Then congestion control. So like TCP, in SCTP, congestion control specifies is there any data or how many data are injected during the network. So few control mechanisms are there for flow, error and congestion in SCTP also. Some special characteristics of SCTP. A unicast with the multiple properties. So normal point-to-point protocol, but it can choose multiple paths to reach the destination. a reliable transmission. So definitely when we go for error control mechanism, we need to identify where error happens. So it gives a reliable transmission. We have a SCTP acknowledgement number and checksums to detect the damaged packets, corrupted packets or discarded packets can be identified. We have a positive and negative acknowledgements number here. So similar to TCP, SCTP is more efficient at the receiver side for reordering of data packets. So whenever any duplicate packets are arrived at the receiver side, it can easily identify the duplicate packets. It's a message oriented protocol. Each message can be framed and we can keep order of the data stream and tabs on the structure. So similar to TCP, here there is no abstraction layer where TCP we need to abstract the data, that is a fragment of data into the data frame. So here we have keep the order of data streams and tabs on the structures. Multi-home can be established by multiple connection path between any two nodes from sender to receiver and does not rely on the IP layer for resilience. Security is the main thing where in SCTP resource allocation for associating the establishment for all the data packets or whatever messages we are forwarding, we have an acknowledgement for each and every communication. So based upon this acknowledgement or negative acknowledgement notifications, few of the attacks like a man in the middle and denial of service or avoided here. So few security control mechanisms are also supported by SCTP. So when we compare with the TCP, instead of sending the packets in a single stream, multiple streams are there and all the streams are controlled by the channel. So this SCTP protocol gives few advantages and drawbacks. It's a full duplex communication and you have some message boundaries are maintained and application do not have to split the messages. It has the properties of TCP as well as UDP protocol. It does not rely on the IP. That's what we have discussed before. And few drawbacks related with SCTP. One of the main challenge here is it has to change in the transport stack on the node. Applications on the any applications that rely on SCTP instead of UDP or TCP, it has to modify its structure. Applications need to be modified to handle multiple simultaneous streams. So since there is no multiple streams in TCP, we need to make the applications that has to handle or not depending on the number of streams that it takes for forwarding the data through the channel. So apart from that, we have a lot of advantages what we have discussed. So when we come across about SCTP, that is Stream Control Transmission Protocol, it will be better when we compare with your TCP. Thank you.